Alright, so right in this video I'm going to be talking about amide, alcohol, aldehyde, and carbonic acid. So right away, this here is an amide right here. Amide, that's what it is. And what it is a carbon double bonded to an oxygen and single bonded to a nitrogen. So this is the important relevant stuff. And the nitrogen will bond off to bonds elsewhere, and then this could be anything else with the carbon. But this combination right here is the most essential. Here's some other part, and then this one's not really that relevant, which I could be wrong in saying, but yeah. And actually, I am sorry to disappoint, but it would seem that I do not have any notes regarding amides. I must have missed that day, being sick and all. I hope you're not too mad, but I'm sure you can find the will to forgive me, yourself, for me from the past. But from the looks of it, it's just what it looks like, and it shouldn't be too hard to name or anything like that. For most part, this is just for recognition, so I'm just gonna go ahead and move on to alcohol. So too bad not learning about that. Alcohol, which is right over here. And what this will be is usually, let's see if I can find the notes for that first actually. But alcohol will be an OH group, so it'll just be sticking out at some bond. It'll be an O and an H, and it's real easy to tell. It's real easy to see. But one thing with alcohol is when naming it, well, let's just start with, so that's what it looks like. But it has different degrees in accordance to what I was learning here. So let's say we have just a carbon, and over here is some different things. Here's the OH group, here's an H, here's an H, and there's some random one. This would count as 1 degree. And actually, let's just write this smaller so I can fit them all in. Let's see. One degree. It's RRH. Alright, so this is 2 degree and this is 3 degree. For the most part, this is just to be able to recognize them. Now, what you'll notice is at 1 degree, it's attached to a carbon which has 2 hydrogen and then 1 other random anything. Could just be another carbon, could be another hydrogen, could be anything. And that's 1 degree. But here we have a carbon still, and now there's only 1 hydrogen and 2 other random anything else. And at 3 degree we have no hydrogen, instead we have 3 of anything else. Carbon could be hydrogen and anything else, but so what you'll notice is that as the number of hydrogen decreases, the degree increases. So that's a good way to remember that. It's not too difficult. So if there's no H, it's 3, because there's, or rather another way to look at it is this number also represents the number of R's. So there's 1 degree for 1 R, 2 degrees for 2 R's, and 3 degrees for 3 R's, which may be what the point of that is. So just hopefully you're jotting this down, because it's going. Hold on just. Alright, I just got a drink. Didn't really help much. I still sound a little, I don't know. But back to this. Let's get something else going here. When naming these, let me just get some examples here. Oops, that won't work. And then, alright. And so here, we could name these, oh, sorry about that. Alright, so we have two different molecules, and just like with many other things, you want to start numbering these off in the way that'll give the OH here the lowest possible number. So we'll start here for this one, 1, 2, 3, and it's 3, so it's going to be propyl, prop. And whenever you're dealing with alcohols at all, whenever dealing with different kinds of molecules or different parts of a molecule, the ending will usually change, such as ane, ine, ene, and those kind of things. So for alcohol, we'll have anol. So propanol is what the name of this molecule would be. And the alcohol molecule is on the 1, so it would be 1 propanol. Prop meaning 3, the number of carbons we have. Anol meaning alcohol, and 1 meaning where the alcohol attaches to, or which, where it attaches to on this molecule. And if you would magnify this, it would be C, OH, and then an R over here, or another one, and then the C itself would have 2 H's implied. So with this, if you took notes, you will notice that it would be a 1 degree, seeing as there's 1 R. And this will make more sense in the next example, hopefully. So, and on this example, numbering won't really matter, seeing as you can start on either one of these. So 1, 2, 3, and no matter which way you do it, 1, 2, 3, the alcohol will always be on the 2. So 2, and it's still 3, so it's going to be propanol again. And if we drew this one out, it would be OH, C, and then it would have, since this is the carbon we're taught, this carbon here is this carbon here, and it's attached off with 2 other ones, so we'll give those the R group. And carbon likes to have 4 bonds, so here's a bond, here's a bond, here's a bond, and then there's one of these is sticking out somewhere, maybe, and then there's 1 H that's implied. And that's another thing with many of these things. Whenever you see structures like these, you'll notice that they have their H's here. You don't actually draw them out. Like if I was drawing out this one, I'm not gonna draw it out like this, because not this one, sorry, I should have looked at it better. Alright, I'm not drawing out this one like this, just that would be incorrect. That would imply that there's carbon, that all these are carbon, except for that one. That was a no. The correct way would be just like that, because this hydrogen doesn't really count when you're just drawing out the lines. It'll be mistaken as a carbon, which you don't want. It's not a carbon, it's a hydrogen coming off of a carbon. So hopefully that didn't confuse you too much. That's just something on the side. But yeah, and since we have 2 R groups here, this would be a 2 degree. And I'm hoping that that makes sense. I really am hoping it makes sense. Let's just do another example, this time without all this, to make it a little more complicated. Sorry if this is hurting your junior stressed out brain, but you'll have to learn this. Alright. And I'm sure I won't be that lazy, but time will tell. Let's see, let's draw out something like this. Mm. And then there's OH here. Alright. I think this is right. This should be right. I like to draw these things out better than finding a picture, just because it's much more fun to draw. So immediately the first thing you do will be find your longest chain. So, and since OH is right here, you're gonna want to give it the lowest possible number. So you're gonna start numbering on this one over here. All right, so 1, 2, 3. Now here you can either go up here and give that one 4, or go down here and give this one 4. But if you give this one up here 4, you go 4, 5, 6, which opposed to this one, which you go 4, 5, 6, 7. So clearly you're gonna assign 4 right here, then 5, 6, 7. So now you know that's gonna be hept. And with this alcohol group here, it's gonna be heptanol. First off. And then I like to just construct it going backwards, so you know that your alcohol is going to be in the 2 group, so I'll just write it here, 2-heptanol, or you could just have 2-heptanol. And then you have 2 methyl groups over here, and 1 propyl group right here. Since you didn't make that your longest chain, it'll become a propyl group coming off of this carbon here. So 3, you have a propyl group, and at 5 you have 2 methyl groups. Now when putting, and I think I made a mistake. Yeah, this here is not a methyl. It is actually has a Cl there, so it's going to be chloro. And I'll explain this a little more in the future, next one that I'll make. But this will be a Cl here. Cl, methyl, and propyl. Now when naming this, you want to consider the alphabet. So what comes first in the alphabet? M, C, or P? C, clearly. So that'll go all the way in the front, and chlorine, or chloro as we're going to call it here, is at the 5. So 5, chloro. And then the next one alphabetic would be the methyl group, so 5 methyl. And then it's going to be the 3 propyl. This 3 propyl group we have here. Anyway, so, and then you just would put this right here. All nice long chain. And you would be done with that one.